So if we're going to review a middle school concept, if I have a fraction and I don't want a fraction is the same thing as a division problem. So if I want to undo the dividing, I need to multiply both sides by whatever the denominator is. Since my denominator is a 2, I am going to multiply both sides by the 2 so that my denominator would end up going away. And why it does is because now I have 2 times this entire fraction, which means I have 2x all over 2 because numerator goes to numerator, equals 2 times 3 is a 6. The 2's end up oneing each other out, and I am left with just a x equaling 6. So we wanted to get rid of the denominator. Same thing with the denominator is a variable. I need the denominator to move. I need the denominator to go away. I don't want a fraction anymore. So since a fraction is a divided by problem, if I were to say that I want to multiply both sides by what that denominator was, I now have x times 4, so this is a 4x all over, technically this is like an over 1 fraction. 1 times x is an x, equals x times 6 is a 6x. I can see that my x's would have oneed each other out, so I have 4 equaling 6x. I have the same exact problem, just one is with a fraction, the other one is not, so I can continue to solve this problem. This is the principle that we're going to use to do today's problems. So I have a fraction plus a fraction equaling a fraction. When I have all of the fractions together, sometimes things start getting confusing. The easiest way to do this problem is to get rid of the fractions. And we get rid of the fractions by finding the least common denominator. So like our other problem, if I see a denominator of an x, that means I need to multiply everybody by an x. I see a denominator by a 5, which means I want to multiply everybody by 5. Denominator x, well, I already actually talked about that already. So we're not going to do him again because we already did him. So I just got through saying that I wanted to multiply everybody by an x and everybody by a 5. So my least common denominator is a 5x, which means I'm going to multiply everybody by that. So again, why? I want this divided by x to go away, which meant I had to multiply everybody by an x. That's why there's an x there. I want this divided by 5 to go away, which meant I wanted to multiply everybody by 5, which is why the 5 is there. I want to make this divided by x go away, but I already actually talked about that, so I don't need to do it again. So everybody is going to get multiplied by our LCD, which is 5x. So this fraction right here, which is 15 over x, he's going to get multiplied by the 5x, plus this fraction of 4 over 5, he's also going to get multiplied by the 5x, equal this fraction of 7 over x, he's also going to get multiplied by the 5x. So original problem got multiplied by our new least common denominator, original problem multiplied by the least common denominator, and then that problem multiplied by the least common denominator. Now these are technically all fractions of all over 1, so if you need to do that so you can see it, you can. Remember, when we multiply fractions, we multiply straight across. So this is a 5x times 15 all over 1 times x is x, plus this fraction is 5x times 4, 1 times 5, there's an equal sign, 5x times 7, 1 times x. Now the whole reason why we did this is because, remember, we were trying to get rid of the fractions. So I see that the x's one each other out, I see that my 5's one each other out, and I see my x's one each other out. The only reason why I'm able to do that is because there is no plus or minusing anywhere in here. These are all multiplications, so they're factors. They cancel out. Same with this. There is no plus or minusing anywhere up in here, which meant these were all factors, which means they can cancel out. Same thing here. So what do I actually have? I have 5 times 15 plus I have 4x equaling I have 5 times 7. So what do I actually have? 5 times 15, I have 75 plus 4x equaling a 35. It's the same problem. We just have the fraction version or the non-fraction version. Now solve for x. And my answer is x equals negative 10. So now we're being asked to solve for x. I have a fraction minus a fraction equaling a fraction. And one of the strategies is to get rid of all the fractions. And the way to do that is to multiply every fraction by each of the different denominators. So I see two different denominators. I see the x plus 1 as a denominator, and I see the 2x as a denominator. The 2x is repeated. That just means that we have two different denominators. One of them just happens to be written twice. So this is our least common denominator. This is what we need to multiply all three fractions by, because that would help eliminate all of our denominators. So each of these individual fractions is going to get multiplied by this. So the entire first fraction got multiplied by our least common denominator, minus the entire second fraction got multiplied by our least common denominator, equal sign. The entire last fraction got multiplied by the least common denominator. Now you can think of all of these least common denominators as fractions all over once. Now when we multiply fractions, we multiply across, so numerator to numerator, denominator to denominator, subtraction, numerator to numerator, denominator to denominator, numerator to numerator, denominator to denominator. Now we're hoping that when we did this, when we go through to see if we can simplify our fractions, we're hoping things won out. So I see an entire factor of x plus 1 both in the numerator and the denominator, so they won each other out. I see an entire factor in both the numerator and the denominator, so they won each other out. An entire factor in both the numerator and the denominator, so they both won each other out. So I see that my denominators all ended up canceling out. That's what we wanted. We wanted the fractions to not be there anymore. So this is a 2x times a 3x, which is a 6x squared, minus, so this is a 5 times an x plus 1, equals, this is a 3 times an x plus 1. So my denominator is canceled out. So what do I actually have? Because I need to distribute this minus 5 into everything here, and I need to distribute this 3 into everything over here. So I've got a 6x squared minus 5x minus 5, 3x plus 3. Now because I have an x squared and an x, that means I want this equation to equal 0 so I could factor it. So we're going to move these to the other side so I could end up factoring them. And before I factor, you're supposed to look for GCF. I see that these can all be divided by 2, so I'm going to divide everybody by a 2. And when I divide everybody by 2, I see that this is the problem I'm supposed to do. Leading coefficient is not a 1, which means I'm going to do a little bit of extra work. So a times c is a negative 12. Somebody better add up to b, and b is a negative 4. Need two numbers that multiply to give me negative 12, but when I add them I get negative 4. I know a negative 6 and a positive 2 multiply to give me negative 12, and when you add these two you get your negative 4. So I have to come over here and use my area model, because this is not a 1. I need to find the extra stuff. So right here is the 3x squared. The negative 4 comes in the back. These two come from the numbers that you just found. So this is a minus 6 and this is a 2. So now my GCF up here is an x, and after I find the 1, everybody else is just a multiplication game. So x times a 3x would give me the 3x squared. X times a 2 gives me this 2x. 2 times a negative 2 would give me this negative 4. And negative 2 times 3x gives me the negative 6x. So these sides are my factors. And now it's a zero product property, so either this parenthesis is the 0 or this parenthesis is the 0. So solve for x. I get x to be 2. Solve for x. I get x to be negative 3/2. So I actually have two answers. So we're being asked to solve for x, and I have a bunch of fractions and then a non-fraction. One of the strategies for solving this is to first get rid of the fractions. To be able to do that, we need to know what each of the denominators actually are in fully factored form. This denominator is fully factored, while this one is not. So we need to go ahead and see if that we can factor it. And you will notice that this is a difference of squares. If it's a difference of squares, you can go ahead and factor it so that it would look like this. Because I know the square root of x is x, the square root of 1 is 1, and because it's a difference of squares, they are different signs. So now I can see I needed an LCD. I needed a least common denominator. I see that they already share a denominator of x plus 1. The only other denominator that no one has yet is an x minus 1. I need to multiply everybody by this because that represents every single denominator of my problem, and that'll help me get rid of my fractions. So each one of these is going to get multiplied by this. So the first full fraction was multiplied by our least common denominator. Now it's this fraction's turn. Now everybody, even this plus 3, the entire problem is supposed to get multiplied by it. So now if it helps you, you can imagine these as fractions over 1. Numerator is supposed to go to numerator. Denominator goes to denominator. Numerator to numerator. Denominator to denominator. And this is already multiplied through, so if we want to just multiply it through, we know that this right here is a difference of squares, so that's the same thing as this right here. This right here, if you multiplied it out, gave you that. So now let's go through and see if anybody ones out. I see this entire parenthesis ones out with that entire parenthesis. I see the x plus ones one out and the x minus ones one out. And now I see that all of my denominators have actually canceled out. So I no longer have fractions. I have the x minus 1 being multiplied to the 4x plus 1. There's no denominator, equals. I see it as I have a 12. And then I have this right here. So now I need to go ahead and distribute into my parentheses so I know what I actually have. So this is x times 4x, so that's a 4x squared. That is a plus x minus 4x minus 1 equals 12. That's plus 3x squared, and that's a minus 3. So combining like terms, 4x squared, this is minus 3x minus 1. Putting this in standard form, 3x squared, 12 minus 3 is a plus 9. X squareds and x's both exist in the same problem. That means I need to make this problem equal 0 so I can factor. So I'm going to move these parts to the other side. So 4x squared minus 3x squared gives me an x squared. That's just a minus 3x, and that is now a minus 10 equals 0. So that equals 0. I want to factor. Leading coefficient is a 1, which means I can automatically write it like this, and I can figure out what I have. I need two numbers that multiply to give me negative 10, but when I go and I add them, they were supposed to give me a negative 3. So trying to think of these numbers, I end up having a negative 5 and a positive 2. These multiply to give me negative 10. When you add them, you get a negative 3. So minus 5 and plus 2. These two parentheses are the zeros, and you're going to solve for x. So x is 5, and x is a negative 2.